are here at the Superbooth 2019 in Berlin. My name is Doepfer. I'm the owner of the company Doepfer Music Electronic. Maybe you know us. I wanted to show you our news we present here at the Superbooth. What you see here is the first line of our Slimline modules. A lot of customers were asking for the standard functions like VCOs, VCS, mixers and so on with smaller panels. Especially musicians who play a lot live on stage have a problem that they have only limited space, and especially for these users we designed the Slimline modules. I will explain a little bit in detail the different modules. What we see here is the A111.3. It's already available since a couple of months. It's a precision VCO behind a 4 HP panel. And what we see here is the prototype of the noise module A102. It includes an analog noise generator with white noise. It also has a colored noise output with controls for blue and red. And it also has a random output, and in addition to the random output, a sample and hold, which is used to sample and hold the random. The next module we see is a miniature mixer. It's a very simple module. It has 4 inputs, which are typically used to mix the outputs of the VCOs and the noise to prepare the input signal for the filter, which we see here, the A121.3. It's a 12 dB multimode filter with the typical features. And finally we have here in the audio chain a dual VCA, nothing but 2 VCAs, which can be controlled independently via linear or exponential control signals. And as modulation sources, we have a dual ADSR A142. It's already available since a few weeks. And the new quad LFO A145.4, it contains 4 independent LFOs behind a 4 HP panel. For each LFO you have a manual control, 2 outputs, rectangle and triangle, and you have an LED for controlling of the frequency. Internally, each LFO is equipped with a jumper where you can select the frequency range. The standard frequency range goes up to about 50 Hertz and down to, I don't know, 30 seconds or so. If you install a jumper, it can be go much lower, up to several minutes. So it's up to you which frequency range you want to have. Well, these are the Slim modules. I don't have an audio example because they are quite standard modules. It doesn't make sense to show you an audio example. It's quite a monophonic monophonic synthesizer with 3 VCOs, VCF, ADSR, envelopes and so on. We also show here a new model. It's the A111.6. It's a complete synthesizer voice in a 10 HP panel. It features a VCO which has 3 waveforms. It has triangle, sawtooth and rectangle. For the rectangle we have a manual control of the pulse width, and we also have a modulation input which can be switched to the pitch of the VCO or to the pulse width of the rectangle. Then we have a filter with the classical controls: frequency, modulation depth and resonance. And what we see here is a little bit uncommon control. It's called balance. The balance control is used to control 2 opposite working VCAs which are in front of the VCF. With the balance control at the left position, the VCO signal is used as source for the VCF. In the fully clockwise position, we have an external input signal, which is now used as audio input for the filter. Internally, which cannot be seen here, the external input is normaled via the switching contact to the sub-octave signal. That means we generate internally also a sub-octave signal, and if nothing is connected to the external input signal, the balance control is used to pan between the normal VCO signal, which can be sawtooth or triangle or pulse width or whatever, and the sub-octave. And very important is also that this parameter is voltage controlled. We have an input which is called CV balance, so you can control the balance also, for example, from a sequencer. So for each step of the sequence you have a different amount, for example, of the sub-octave or from an external signal. If an external signal is used, typical application is that you have a second VCO in addition to the one VCO which is in there. And a little bit about the envelope generator. It's basically an ADSR, but you see only two controls. That's why the sustain is fixed to 50%. There is a trimming potentiometer in there. If you want, you can change the setting to another percentage, but the standard is 50%. And the decay and release time are the same. This is why we have only two controls. One is for the attack time and the other one is for the decay and release time. And we have a mode switch. In the upper position we have an attack decay, in the center position attack decay sustain release, in the lower position attack release. So we have three different modes of the envelope generator. And finally we have a VCA, which you see here. We have a manual gain or initial gain, it's like that. And we have a switch where in addition to the initial gain we use the gate signal or the envelope signal to control the VCA. So it's possible to control the VCA via the gate signal on-off with a gate signal, or use the internal envelope to control the VCA. Okay, if I turn up the initial gain, we hear also the synthesizer voice working. Pretty standard. What I want to show you is the function of the balance. We switch to sawtooth. So this is the sawtooth, and if I operate the control, the sub-octave comes in. And this function, as already mentioned, is also voltage controlled. Yeah, I think a lot of functions behind 10 HP only. Okay, and a few words about our polyphonic modules. They are already available. It's not new here at the show. They are available since a couple of weeks. What we have available is the polyphonic USB MIDI CV interface. It's an interface that is used to connect a MIDI sequencer or a MIDI keyboard and generate from the signals coming from the keyboard or the sequencers the CV and gate signals required to control the polyphonic synth. What we see here is a classical 4-voice polyphonic structure. We have 4 VCOs, 4 VCFs and 8 VCAs, and separate envelope generators for the filter and for the VCA. And if I play on the keyboard, it's pretty what you would expect from a 4-voice polyphonic keyboard synthesizer. And we see here another relative new module. It's voltage controlled multiple switch win. I use here to switch the gate signals from the interface to the trigger sequencer. That means if I switch over there, now the gate signals are no longer coming from the keyboard, but from the trigger sequence. So in this example, the CVs which generate the chords are still coming from the keyboard, but the trigger signals are coming from a trigger sequencer. It's one example to show that you not just have to build a standard polyphonic synthesizer from the modules, but you can use different CV sources, different gate sources coming from the modular system and use it in a polyphonic context. The idea is not simply to build a polyphonic synthesizer. I say to customers, if you want a polyphonic synthesizer with keyboard, buy a polyphonic synthesizer. But you can now introduce polyphonic structures into the modular. Yeah, that's what I wanted to show you, and thank you for coming, and bye-bye.
Thank you.